I am Joanna S. Lucas from BSCE1E, and this video is for my subject, Physics for Engineers.
Hi, I am Joanna S. Lucas from BSCE1E. This video is for my subject, Physics for Engineers. In this video, we will talk about how we can solve a problem about forces in 2 dimensions. So, before we start solving, there is a way how we can solve it easily. It is to treat each coordinate direction independently of the other. And also, we will resolve each force into its x and y coordinate for us to solve it easily. So, let's solve the problem. Our problem is, come first lift a food cooler with a weight of 192 Newton using 2 ropes hung over hung over 3 branches. Rope 1 exerts a force with a magnitude of 166 Newton at an angle of 47.4 degrees above the horizontal. Rope 2 exerts a force at an angle of 36.1 degrees above the horizontal. In this problem or in this situation, we have 2 questions that we need to answer. First is find the magnitude of the force F sub 2 that produces a net force on the cooler that is straight upward. Second, determine the net force acting on the cooler. So, before we start solving, we have to draw the problem first for us to solve it easily. So, this will be the cooler of the campus, and this arrow will be the force or the rope that is lift the cooler up. So, this will be the F sub 2 or the force 2, and this will be the F sub 1 or the force 1. In F sub 1, we have angle 47.4 degrees. So, this angle will be at the handle of the cooler and the rope. And the F sub 2 will be at the 36.1 degrees, where like in the F sub 1, it is angle from the cooler and from the rope. So this will be the weight of the cooler since the gravity is downward. So this, after illustrating it, we will now use a free body diagram. So this will be the x and y coordinate or x and y axis. This will be the y and this will be the x. So the x axis will represent the handle of the cooler. So this will be the cooler, and the origin will be the place where the rope tied. So this will be the 2 rope where force 1 and force 2 produced. So the angle here will be 47.4 in force sub 1, and for force sub 2 is 36.1 degrees. And in the y-axis downward, this is where we can find the weight of the cooler. So since our F sub 1 is at the left side of the x-axis, we are expecting that the x-axis value of the F sub 1 is negative. So let's now answer the first question, where we are asked to find the magnitude of the force or F sub 2 that produces a net force on the cooler that is straight upward. So before that, we have to apply here the equation from kinematics, where we use every time we are asked to find the magnitude. So since F sub 1 y is equal to F sub 1 sine theta, or the degree or the angle of the f sub 1, which is 47.4 degrees. So f sub 1y is equal to f sub 1 sine of 47.4 degrees. So for f sub 1x equals to negative f sub 1 times cosine of its theta, where 47.4 degrees. So our f sub 1x is equal to negative f sub 1 times cosine of 47.4 degrees. So like what I've said earlier, the f sub 1x will be negative since it is in the right side or in the left side of our x-axis. And because of our f sub 1y, it is positive since it is at the upward of our y-axis. So for our f sub 2y is equal to f sub 2 times sine theta, or the theta of the angle of f sub 2, which is 36.1 degrees. So our f sub 2 is equal to f sub 2 is times sine 36.1 degrees. And for f sub 2 y, it is equal to f sub 2 times cosine of 36.1 degrees. Since we have sine and cosine, it is because of its axis or where its position. Since our y here, f sub y and f sub 2y and f sub 1i, y is at the y-axis, our trigonometric function we use is sine. And since f sub 1x and f sub 2x is cosine, it is because the position of our force here is at the x-axis since it is cosine. So after that, we can now solve the first question. For us to find, since the summation of f is equal to the force that is acting, is equal to all forces that is acting on our problem, we will use addition here. Since we have two forces happened in this problem, we will use summation of f is equal to f sub 1 plus f sub 2. Since our summation of f is equal to 0, we will use this equation for us to solve our magnitude in f sub 2.
For us to find f sub 2, we can use the formula for summation of f, where summation of f is all the forces in the problem. So we have two forces here, which is f sub 1 and f sub 2. Our formula will be summation of f is equal to f sub 1 plus f sub 2, since we just have two forces happened here. So summation of f is equal to 0. And this is also our given for this question for us to solve our f sub 2. So our formula will be summation of f is equal to f sub 1x plus f sub 2x. We are finding here the forces happen in f sub x, or in the x-axis. So we will substitute it now. Here we have f sub 1x is equal to negative f sub 1 times cosine of 47.4 degrees. We will just substitute it. F sub 1x is equal to negative f sub 1 cosine of 47.4 degrees plus our f sub 2x, which is f sub 2 times cosine of 36.1 degrees. So this is our equation in this problem, and we will replace summation of fx to 0 since it is equal to 0. So 0 is equal to negative f sub 1 times cosine of 47.4 degrees plus f sub 2 times cosine of 36.1 degrees. Since this is 0, we can move our f sub 1x in the other side of our equation. So it will be positive. The f sub 1x na will be positive since we move it in the other side. So f sub 1 times cosine of 47.4 degrees is equal to f sub 2 times cosine of 36.1 degrees. Since we are asked to find the f sub 2 here, we will cancel the cosine 36.1 degrees. And for us to cancel it, we will divide both sides in cosine 36.1 degrees. So let's divide it now. F sub 1 times cosine of 47.4 degrees over cosine of 36.1 degrees equals f sub 2 times cosine of 36.1 degrees over cosine of 36.1 degrees. And now we can cancel the cosine of 36.1 degrees in f sub 2 for us to have the equation for looking and to equal the f sub 2. So cancel our cosine of 36.1, and our equation now will be f sub 2 is equal to f sub 1 times cosine of 47.4 degrees over cosine 36.1 degrees. So since we have given here that the magnitude of f sub 1 is 166 Newton, we can replace this f sub 1 to 166 Newton. So f sub 2 is equal to f sub 1, which is 166 Newton times cosine of 47.4 degrees over cosine of 36.1 degrees. So calculating this, we will get the equal of 139 Newton. So our f sub 2 is 139 Newton. The magnitude of f sub 2, or the magnitude of force in f sub 2 is 139 Newton. After answering the first one, we will answer the second one, which is we are asked to determine the net force acting on the cooler. Since our cooler is if this is being asked, we are asked the direction of y-axis. Since the rope lift it up, so it will be moved vertically upward. So our equation here will be summation of f sub y is equal to, like earlier, the forces, which is f sub 1 y plus f sub 2 y. Since we are asked here the force acting on the cooler, which is we need to use the y-axis since we lift it up, or the rope lift it up. So summation of fy, or f sub y, is equal to f sub y. So our equal here, or the given here, like the one we write earlier, is f sub 1 y is equal to f sub 1 sine of 47.4 degrees plus f sub 2y, which is f sub 2 sine 36.1 degrees. So after knowing that, we can now substitute the given that we get earlier, which is the 139 Newton for f sub 2. So our equation here, or our given here will be for f sub 1, at this is from the given, which is 166 Newton, and for f sub 2, which is from the question we asked earlier, which is 139 Newton, this will be the given that we will use in answering the forces acting on the cooler. So f sub 1 times sine of 47.4 degrees is equal to 166 Newton times sine 47.4 degrees plus our f sub 2 sine of 36.1 degrees, which is equal to 139 Newton times sine of 36.1 degrees. So calculating this will be equal to positive 11.9 Newton. Our force acting on the cooler is 11.9 Newton. So that is our answer in this problem, which is the magnitude of force sub 2 is 139 Newton, and for force acting on the cooler, the answer is 11.9 Newton. So that is how we can solve a problem about forces in 2 dimensions. That's all. Thank you for watching.